Now we're getting a little bit closer to why we would use the IVT. We have a particle moving horizontally, and selected values are given on this table. So we need to explain why there must be a time on that interval between 0 and 8 where the particle changes direction. In this case, we know we want to use the IVT. And remember, we have to show that if the hypothesis part is true before we can try to do anything else. So we have to prove that the particle, well, it says it's given by a continuous function, so we're going to note that. Okay, the particle travels continuously on that interval. Now, how do we know that the particle changes direction? Well, look at this. Since this part is negative, okay, we look, that's negative velocity, and this part is positive. I'm going to use our fancy terminology here. There exists some t value on that interval from 0 to 8 such that the velocity is 0. And we could say by the IVT. We don't have to find it. Okay, we just have to know why there must be. So if the particle is going backwards and then it starts going forwards, somewhere, if it's moving continuously, it has to change directions. We can also do this with functions. Show that there's a positive real solution to this. It doesn't say we have to find what it is, but we have to show that there is one. And sometimes it's easier if you change it so that there's one function. There you go. All right. So you can just try picking random numbers here and see if you get a positive one and a negative one. But before we try to use the IVT, we would say f of x is continuous for all real numbers because it's a polynomial and all polynomials are continuous. Let's see. Let's try some easy numbers here. Maybe 0. We get -2. Try 1. 1 minus 1 minus 2. Well, that didn't help. And let's see, maybe we could try 2. -4, that would be 28, I believe. Oh, look, that's negative. That's positive. That's going to help us, okay? So we could say since f of 1 is negative and f of 2 is positive, there must exist. You can write that, or you can just say there exists by writing that big fancy backwards capital E. There exists some x on the interval between those values, 1 and 2, such that f of x equals 0, and I'll just restate at the beginning, x to the 5th equals x plus 2 by the IVT. There you go. It's not so bad. Example 9 is similar. I'd like you to do that in your whisk. Be careful. I want to see your wording. How do you word that? Because that's important to practice using that. Okay, and then we have example 10 here. Sometimes you're going to see a graph. Sometimes you'll just see a function. And sometimes you see a table. You have to be fluent between all of those things. So this is important. You're going to see things like that. It's continuous. So maybe we have to use the IVT here. We're going to just say, hey, h of x is continuous for all real numbers, since f and g are continuous for all real numbers. Now, we're going to find some value between 1 and 3. So let's check it out. H of 1, well, that's f of g of 1 minus 6. G of 1 is 2. And let's see, f of 2 is 9. 9 minus 6 is 3. H of 1 is 3. H of 3, that's f of g of 3, minus 6. G of 3 is 4. So if we do f of 4 minus 6, f of 4 is negative 1. Minus 6, that's negative 7. All right, I might run out of space here, but we stated the hypothesis is true. So we can say that h of x, oh, let's say since. I like to use since. Since h of 1 is positive. Oh, we aren't doing positive, are we? We're trying to find somewhere where h is negative 5. But that's okay because negative 5 is still in between 3 and negative 7. So let's say since h of 1 equals 3 and h of 3 equals negative 7, and just to state, we can say that negative 5 is between 3 and 7. You could do something like this, or 3 and negative 7. Since those are true, there exists some r, since they told us to use r on that interval from 1 to 3, such that h of r equals negative 5, since, we could say that, negative 7, since negative 5 is between 3 and 7. That's a kind of a better place to put it, okay? Something like that. So the wording gets better as you practice it. You may or may not have this in your notes. If you do, don't worry about it. But this is how, when the AP exam was given and this question was on there, this is what they expected you to do. You got a point just for figuring out what h of 1 and h of 3 were, and then you got 1 point for your conclusion using the IVT. I don't know if I said by the IVT on my last problem. I should go back and look. Oh, of course I did. By the IVT. Okay. Ooh, that was a close call. Okay, so if we look at what they said, since h of 3 is less than negative 5, and h of 1 is greater than negative 5, and h is continuous, by the intermediate value theorem, there exists some r value between 1 and 3, such that h of r equals negative 5. That's just a different way of wording it, and you'll get a little bit better. Funny thing is, I actually took the 2007 AB calculus exam. I'm going to assume that I was one of these people who got 9 points to bring up the mean, but we'll see. All right.